Okay, hi. Can everybody hear me? Is my mic level okay? Excellent. Right, well, thank you all for coming. This is the sort of first in a series of webinars I'm going to be doing about Cel-Fi. I thought a good place to start would be just explain the legality, because that's by far the question we get asked the most. As I'm sure some of you are aware, there have been solutions for this sort of thing available for a while, but they've actually been illegal, and I know some people have been slapped with fines from Ofcom and things like that due to sort of getting found out to have been using them. So I thought I'd just go through and clarify exactly where Cel-Fi stands on legal standpoints. And I also thought I'd explain a little bit about what Ofcom does and how the product actually deals with the sort of the restrictions set by Ofcom. This is part one. Next week, I will be doing a webinar at the same time about how to cable for mobile solutions. And then I think in January, the next one will be actually talking about the specifics of the products. After next week, I'm on holiday for 2 weeks, and then we have a guest speaker, which is a chap from HD Anywhere, who's going to talk about the new HD Anywhere matrices that are coming out. So he'll be taking the 2 weeks after that, and then I'll be back to do some more Cel-Fi. So a little bit about me. My name is Joe Fletcher. I'm the head of technical services for OneAV. My job is to essentially oversee all sort of technical support issues, but also deliver training. When we onboard new products, I sort of take those over and make sure everything works okay and understand how it works. And I've spent a lot of time with Cel-Fi. It's a product we really spent a lot of time researching and learning about. And now I spend a lot of my time visiting our customers' sites to look at how we can implement Cel-Fi solutions for them. And then next, a little bit about OneAV. So I don't know if you're all OneAV customers already, but OneAV, we describe ourselves as sort of a new distributor. We tend to focus on providing solutions where perhaps you might not know what you're doing. So what we tend to do is you come to us and you ask, how would I do this? How do I achieve this end result? And we will help you do that. So before I begin, you'll notice there is a questions section at the bottom of the screen. By all means, just type your questions there, and then at the end of the talk, I will answer all your questions, or type them in the chat bar, whichever works for you. We'll have time to go over those. Great. So the goal of this session is, by the end of it, I want you to be able to understand Ofcom's stance on mobile repeater technology. I'm going to make sure you understand the requirements a product needs to be legal, and I want to sort of you to know how Cel-Fi achieves that. So a little bit of information about Cel-Fi themselves. Cel-Fi are actually an American company. Well, they are American. They're owned by a company called Nextivity, who bought them a few years ago. So for some background information, mobile boosting has been available in the States for years and years. And Cel-Fi built the company up on providing mobile boosting solutions. There has never been any legality issues in America, because, to be honest, when you have a country that's that big and has that many coverage problems, a product like this has to exist. Whereas in the UK, because we deal with much smaller areas, that is why we can sometimes create some issues with mobile boosting. So to start off with, let's discuss Ofcom. So the process that allowed Cel-Fi to become legal actually began in 2014. So in 2014, Ofcom began conducting a survey essentially to ascertain if mobile phone providers themselves were doing enough to improve coverage situations all over the country. So essentially, were mobile phone providers putting enough investment into improving their infrastructure in the UK? The reason this became of interest is essentially Cel-Fi and a couple of other companies approached Ofcom to say, we don't believe it's fair that we're not allowed to sell our products in this country because the mobile providers themselves are not doing enough to improve the situation. So this was the result of that survey. And essentially what you can see is a vast majority of people, so over, in most cases, 60% of people in rural areas reported issues with mobile phone coverage. Obviously less in urban areas, but as you can see, there was definitely found to be an issue with the coverage people were experiencing. So looking at the timeline, what essentially happened was, I'm not going to go through all of this, and anyone who wants a copy of this after it's finished is more than welcome to. You get a recording, but as well as that, you also get a copy of the slides. So Cel-Fi have been working with Ofcom for a long time to essentially custom make a product for the UK that would meet their specifications to become legal. So this process has been going on forever. Cel-Fi have been involved from the beginning in terms of trying to work their way through all these licensing issues to get to a point where we could release a product that would actually be legal in the UK. And we finally achieved that last year. So April 2018, Ofcom published a new document, and in that document they outlined what was required for an RF repeater. So that is fundamentally what Cel-Fi is. It's an RF repeater. But what an RF repeater needed to, what standards it needed to conform to actually be legal. So if you would like to see that document, you can see it here. So there's a bit link here. This is the link to that document. So if you're curious, have a look. What I'm going to do is if you don't want to look at it, I'm going to go through the really pertinent bits of that document and explain how Cel-Fi addresses that shortly. It consists of two parts. So within there is two parts. IR 2102.1, that is the minimum requirements for use of static mobile phone repeaters for indoor use. There is also a part about low gain mobile phone repeaters for in-vehicle use. Interestingly, we don't sell them because it's not really our area, but if you are interested in getting a mobile booster for your vehicle, we can certainly point you in the right direction of where you can get that. Cel-Fi also make one of those. So if that is something you think would be useful for your work, by all means, let us know and we can get you some information about that. But essentially, IR 21021, these are minimum requirements for use. Cel-Fi products adhere to that entirely. So that is the Ofcom document that needs to be adhered to. So Ofcom is what we use in the UK. In Ireland, I'm not sure if anyone in today is from Ireland, but is known as ComReg. And ComReg also have their own document, but actually it's a lot less stringent than it is in the UK. So these products are also completely legal in Ireland, and they're the same products that we sell in the UK. So to give you some information about how mobile boosting works and what we're actually boosting. So in the UK, there are 4 bands that are used for mobile phones. That's band 20 at 800 megahertz, band 8 at 900 megahertz, band 3 at 1800 megahertz, and band 1 at 2100 megahertz. Now, what essentially happens is the UK government owns this airspace. And what they do is they sell chunks of it to various companies for various uses. So all the big 4 mobile companies, so that's EE, 3, Vodafone, and O2, they all own a chunk of this. So they might own, a company might own sort of 10 megahertz in band 1 and 10 megahertz in band 20. And that is the airspace that they use for their mobile phone signals. And so one part of the specification is that a mobile phone repeater can only boost these bands. The reason I mention this is there is actually another band called band 7, and then we're not allowed to boost that band. And the reason is it is used for mobile phones in some areas, but actually in most areas it's used for airports and military and just general sort of services use. So it's used for police radios in certain situations where they can't use radio and they have to use mobile technology. So we're not allowed to boost band 7. But most mobile companies don't own any chunks of band 7. EE and O2 own a little bit of it, but they don't use it very often. So just to give you an overview, so most companies use these bands for different things. So band 20 is almost always used for 4G. Band 8 is for 2G and 3G, 2G and 4G, 3G and 4G for band 1. Now, the reason we use band 20 for 4G, so 4G is the most, obviously the most desirable signal. The reason band 20 is used is this signal is at 800 megahertz. And I'm not sure if you're aware of this, but the lower a frequency of a signal is, the better it is at penetrating through objects. So things like glass, plaster, steel, that sort of thing. The lower a frequency is, the better it can penetrate. That fact will become important shortly, and you'll see why I've mentioned that. So this is band 20 and band 1 are by far your standard bands. Most mobile boosters that we install end up choosing to boost band 20 and band 1 because that gives you your good 4G coverage and 3G coverage as well. You'll see that there is actually some 2G. So currently there is still out there a bunch of devices that rely on 2G. There's some phones still out that are still purchasable that only use 2G. And all your phones currently can still use 2G as a fallback. So it is useful to have it there. But the way most mobile boosting devices work is they choose 2 bands that they can boost. There is one product, Cel-Fi actually does 3. But most of them, sort of Quattro and GoX, which are the ones we'll mainly be talking about, they choose 2 bands, and generally that tends to be band 20 and band 1 to give full coverage. So the reason I mentioned the frequency is a question we get asked pretty much on a daily basis is, what about 5G? Now, just to clarify a couple of things, 5G doesn't refer to 5 gigahertz frequency. It's not like a Wi-Fi system that uses sort of 5G and 2.4G. The 5G for mobile phones actually refers to being the 5th generation of technology. In the UK and Ireland, current thinking is that it is going to be deployed on the 3,300 to 4,200 megahertz range, in addition to using some of the lower frequency ranges for better indoor coverage. So what will actually happen is all these frequency ranges will start being sold off by the government to the mobile providers, and they'll start picking up their chunks of frequency they're going to use for their 5G deployment. But what will most likely happen is some of the lower frequencies will be refarmed. So my understanding is currently there are plans to start turning off 2G support and using some of those lower frequencies for 5G as well. Now, in terms of releasing hardware that is going to support 5G, we're not going to see that for a while. The reason is actually 5G doesn't do anything to help the issue of poor mobile signal. 5G is almost entirely about network speeds. So the reason they're using these higher frequencies is that allows them to have faster internet speeds. So if you have poor coverage, so you struggle to make a call in your house, 5G being released isn't going to do anything to help that. So that is not what it's for. And the reason is, as we go back to what I was saying earlier, is that 5G uses faster waves, and as such, it struggles to penetrate even glass. So 5G will be great when you're outdoors. When you're out and about, you probably have fantastic internet speeds, but actually in terms of coverage, it's not going to do anything to fix that. So there will still be a demand years from now for 4G and 3G mobile boosters indoors, because what we're fundamentally trying to do is get people decent phone reception in their houses. So if we just go into some specifics of the Ofcom regulations and how Cel-Fi deals with that. So the first one, this is I apologize for the wall of text, but this is the only one really. These are just the specific regulations that the devices have to achieve. So the uplink and downlink system gain repeat shall not exceed 100 dB. What that means is, to conform to Ofcom regulations, the maximum amount of power a booster can provide to a signal is 100 dB. I can tell you that some of the illegal repeaters out there can do far beyond that, and that creates a problem that I'll explain later. But there is a hard limit. So if a product is legal, it has to have a hard limit of 100 dB signal gain built into it, and Cel-Fi has that. Essentially, that is to do with something called BSCL, which is base station coupling loss. Essentially, when the signal is transmitted from the base station of the mobile provider and then picked up by the repeater, there is amount of signal being lost. And what the unit is not allowed to do is the unit is not allowed to boost the signal beyond however much power the base station originally had. So the base station was delivering at minus 95 dB. When the booster picks up the signal, it's not allowed to increase it beyond that. So maybe when the booster receives the signal strength is minus 75 dB, at which point it can only add 25 dB of power into that signal to stay within Ofcom regulations. That is why Cel-Fi is known as a smart repeater. It has the technology inside it to do these calculations and work out how much it can legally boost a signal by. The next section is automatic standby. So all Cel-Fi products, if they do not detect a mobile device active for more than 5 minutes, they go into basically quiet mode. So they severely drop their power, and they'll only reactivate when a phone is detected again. Anti-oscillation. So this is the really important bit, and this is how the real sort of cleverness of the Cel-Fi technology. Oscillation is the reason most of the time that sort of mobile repeaters were deemed illegal, because essentially they create a problem. Oscillation is what happens when a signal is picked up again and again and again. So it's like feedback. So the real cleverness in Cel-Fi, and as far as I'm aware, this is unique to them, is they have a chipset that is able to detect oscillation and mitigate it. I'll explain in the next slide, I think, how they do that. So oscillation is caused by antennas picking up and repeating their own signal, and Cel-Fi mitigates this. So to explain, oscillation is what happens when, if you've got an antenna on the roof and it's picking up, so the blue signal is sort of the proper signal, and then the red signal is the internal signal that's been generated. Oscillation is created when the antenna that is, say, on the roof is also picking up the signal that is being generated inside the building. And what happens is you essentially get a feedback loop. So the device is constantly just looping the same signal over and over. And what that actually does is creates noise. So an illegal repeater, what it could do is, if you had an illegal repeater and just cranked up the gain, so it was a really powerful signal, what it would start doing is that signal would start looping, so you get a noisier and noisier signal, and then houses down the road and houses that are 200 meters away, their phones would start picking up this noisy signal that's been generated. So actually, an illegally installed repeater could essentially break people's phones in a certain area, because all it was doing was generating a very strong but a very, very poor noisy signal. And that is why Ofcom started fining people, because it was actually ruining it for everyone in an area when you had these illegal repeaters, because it was just like a massive feedback loop, and all you were getting was a signal that your phone thought was a proper signal, but actually it was just noise and it was just garbage. So what Cel-Fi does is Cel-Fi detects, and this is the really clever bit about it, it has the ability to detect its own signal. So what it does is it receives the signal on the roof, pumps it around the building, but then if the antenna on the roof starts picking up its own signal, it dials down the gain. So it actually adjusts its volume effectively so that the antenna on the roof can't pick up its own signal. And that way you get a very clean boost. You get very low noise, high quality signal around the building. Now, what you then have to do is that comes into project planning, because if you know it does this, and this will be a subject for the webinar next week, if you know that what you want to do is minimize the amount of signal that your aerial on top picks up, you can design your project in a certain way so that the internal signal can be boosted as much as possible without the antenna on the roof actually picking it up. And this is huge. This is by far the biggest mistake people make when they're installing this type of product. And the reason these things were illegal for so long is because they had too much gain and they just created this problem. Cel-Fi doesn't have this problem. It's a smart repeater, so you don't have to worry about this. What's next? And the last thing, and this is well worth knowing, is that there is a rule that each device can only support a single operator. So there is no possibility of a box at the moment that does all 4 networks in one box. What you can do is install 4 separate systems. So at the moment, I'm spending a lot of time specifying systems for buildings and MDUs and hotels and things like that, where they want coverage for all 4 networks. And what you end up doing is actually putting in 4 separate systems. There are some ways of having some elements of that system use the same cabling infrastructure, but fundamentally, there's 4 pieces of hardware for each. There's a piece of hardware for each network, so 4 pieces total. There's currently no way of getting around this. We're hoping that Cel-Fi are currently engaging Ofcom about the possibility of releasing a product that does more than 1 network in one box. We'll see. Watch this space for news on that. But currently, if you're specifying a Cel-Fi project, you need to know how many networks they want coverage for. You can't just put one box in that does everything. What you can do is you can put one box in that can be changed, so all the devices can have their operator changed, but you need to know what operator they want. So that is the end of the presentation. Now, does anyone have any questions or anything I haven't covered that you'd like to know about? Anyone? Okay, Ryan, what's your question? Our repeaters over. Oh, sorry, I've also seen a question from Scott, so I'll answer Scott's question first. Some of them are. So some there is the GoX that is over RF. So all the products require an antenna that is connected to the main box via RF. You can't get around that. But then there's a difference in the products where some products use RF around the house and some products use CAT over the house. So the sort of higher end Quattro system that Cel-Fi do, that actually uses CAT cable. So you've got PoE receivers and things like that all over the house, but you still need that fundamental RF backbone to actually get the signal from the antenna down to the box. So the answer is TR repeaters over IP. Some of them can be, some aren't. But no, it's not. For IP, I've sort of assumed your question is it over CAT? It's not actually. None of it is over IP, so none of it is over the internet. It's always a proprietary link, like you just put in your comment that I've just seen. Ryan's question. So in a residential property, how would this system typically be set up? In a very basic residential system, what you would have, and I have a slide here that sort of describes it a little bit. So on the antenna, you would have on the roof, you would have an antenna. From there, you would have a run of RF that goes to one of the main products. So that could be a GoX or a Quattro system. Then from that box, you would have RF or CAT, depending on the product, running to the individual locations where you might be putting your internal antennas. So in the case of this diagram, there's an antenna on the roof, and then on the top floor, there is a run that has an antenna, and then there is a run of cable going to the antenna on the bottom floor. So that would cover both floors of the building. So that is the most typical. In a standard 2-story house, you would have antenna on the roof, RF down to the main, wherever your rack room is. And then from there, you would have either RF or CAT, depending on the product, running to each floor, where connected to that, you would have one of 2 types of antenna, depending on the shape of the floor. And we'll cover that sort of in the next webinar. But that's basically, it's actually very similar to something like a video matrix or a Wi-Fi distribution system. Does anyone have any other questions? Okay, so that's a good question. So one thing to be aware of with this is it is a repeater. So it's not magic. If you've got no signal outdoors, you're not going to be able to bring anything indoors. What it does is it takes what is outdoors and brings it inside. So if you can get a reasonable signal, it doesn't have to be fantastic, just a reasonable signal outdoors. And remember that even if you're on the ground and you haven't got great signal, odds are if you go high up, so if you put an antenna on a pole, it's always going to get better the higher you go. So what you're really looking for is, if the signal inside the house is poor, that's fine, that's not a problem. What you need to know, if you were finding out if you could do this, is there something outside you could work with? You know, is there, if you go outside, and we'll discuss it more in another thing, but there is various apps. If you've got an Android phone, there's a fantastic app that can give you tons of information about the quality of the mobile signal. Unfortunately, there isn't an iOS version, but by all means, ask me about it. I'll tell you about that app. It's called Network Cell Info Lite, and it's available for Android. But what I do is I go and I walk around outside and I find out things like what area the base station is, and based on that, I can work out where I should be positioning my antenna to get as good a signal as possible. If you can get a good signal outdoors, this product very easily allows you to bring that same signal indoors. So if they've got a basement with nothing, you can easily provide mobile coverage in that basement. Does that answer your question? Exactly. Yeah, you've nailed it exactly. So if they're complaining of poor, mobile reception, if you can go and say, look, what we can do is install a repeater. So we are going to look outside. We can see this quality of signal you get outside. We can use a repeater to bring it inside. So that is what you should be looking for. When I'm doing a survey, what I'm doing is basically, it's nothing super high tech. I am walking around and I'm understanding where the signal is poor and where it's good, and then I'm looking for ways and cable routes I can take to bring that good signal indoors. Great. What we'll do is we'll get you some more information. If you haven't, I'm not sure if you've got an account with us, but if you haven't, I'll get a price list over to you after this. Unless anyone else has got any other questions, let me just check the questions. No more open ones. I'll be leaving it there, but by all means join me next week, because what we're going to do next week is I'm going to go over the cabling. It's not standard RF cable. There's a few things you need to know and understand about how best to cable for this sort of thing and best practices with it. But I really appreciate everyone coming. Thanks for coming to our first webinar. I hope it was informative, and we have some extra bits after this. So by all means, follow us on Facebook, Twitter, Instagram, and LinkedIn. You can, or ask any questions. Everyone is welcome to. In fact, I'm just going to put my email address in the chat. By all means, if you have any extra questions you didn't have a chance to ask, just send me an email and ask your questions, and I will get back to you immediately. Thank you very much. I really appreciate it. Bye-bye.